Now that hopefully we're familiar with solving absolute value equations, now we're going to move into solving absolute value inequalities. At the end of this lesson, you'll be able to solve and graph an absolute value inequality. All right, we're just going to look at some examples using absolute values and what their answers would be. The first one, it says the absolute value of x is equal to 2. So we're just going to try to graph and write what values would work. So I know just from our previous lesson that x would equal 2. So I'm going to go ahead and put 2 on my number line. And then the other number that would work would be negative 2. I guess we could put 0 in the middle to kind of ground it. And that's it. So that's my answer would be x equals 2 and x equals negative 2, and we are done with that problem. Okay, now let's introduce an inequality in here. So we're just trying to think of all the numbers that I could put in here so that when I take the absolute value of that number, I will get a value that's less than 2. So I'm going to keep 2 and negative 2 on there just because I'm guessing they'll be somewhat important. But now I'm just going to try to think. So I know that 1 would work. I know that 0 would work. Oh, I didn't give myself enough spaces. I know negative 1 would work. I know 1.5 is less than 2. I know 1.2 is less than 2. I know all these numbers in here. If I take the absolute value of them, I'll get an answer that's less than 2. So you'll notice we've got all of these values in here. And then if I tried 2, the absolute value of 2 is 2, but 2 is not less than 2. So I'm going to leave that an open circle on that side. And then same thing over on this one. If I plug negative 2 in there, the absolute value of negative 2 is 2, and 2 is not less than 2. So that one also does not work. Notice again, there's no equal sign, so that's why my circles got closed in. So now if I wanted to describe what this was, it's a connected graph. I know x is in the middle. X is less than 2, but it's bigger than negative 2. So that's what it would look like as an equation or an inequality. Okay, now let's think of all the numbers that are bigger than 2, the absolute values that is. All right, so if I did that, first of all, I'm just going to think I know 3 would be bigger than 2, 4 is bigger than 2, 5 is bigger than 2, 2.5 is bigger than 2. Whoop. All of those values are. And then negative 2, negative 3, if I take the absolute value of it, will be bigger than 2. Negative 4, negative 5, negative 2.5. So you'll notice I'm kind of getting all the numbers going to the left and all the numbers going to the right of 2. Whoop. And then at 2, again, just like we plugged in on the last one, negative 2 and 2 do not work. So that's what it would look like. And you'll notice this is an unconnected graph, which is usually we have the word or there. So this would be x is less than negative 2 or x is greater than 2. So this is just an idea of what we will end up with when we're done. This is what my answer should somewhat look like as I'm working through these. All right, you'll notice hopefully when we have, to help out, when we have an inequality and there is a less than sign, when we go to solve this, we would end up getting a connected graph because of the less than from the previous example that I was just working on. So the way that we'll want to write this, it will just make it easier for us. You'll notice ax plus b is going to be less than c, and ax plus b is going to be greater than negative c. Notice what I did when we rewrite this equation. This less than c stays the same, and then just like with an equation, we also set it equal to the opposite, which I did here, but notice the less than sign changes to a greater than sign, right? And then the inequality absolute value ax plus b is greater than c is going to be equivalent to or, because we saw in the previous example that you get a disconnected graph. Notice on the first inequality, the greater than c just stays the same. And then the next one, the c changes to its opposite, and the greater than sign turns to a less than sign. So if we can remember these two properties, your life is going to be a lot easier as we go to solve these. So let's try some. All right, let's say I have the absolute value of x is less than or equal to 3. All right, using the property that I just did, before we graph it, we really want to actually write our equation first. So this is going to be x is less than or equal to 3. And we'd actually put an and because this is going to be a connected graph because it's a less than sign, and x is greater than or equal to negative 3. Okay, I'm going to write it like this, but then I'll show you another way to write it when we're done. So I need negative 3 on my number line and 3. Just put 0 in there to ground it. Okay, less than or equal to 3 would be a closed in circle at 3 pointing to the left. Okay, x is greater than or equal to negative 3 is going to be a closed-in circle pointing to the right. So notice just naturally we get a connected graph, which is what we wanted. Okay, and then if I were want to, you may leave your answer just like this. I could also rewrite this so it looks like this. So either one of those answers is 100% correct. Okay, the next one I have the absolute value of x is greater than 5. Right, so this one, again, I'm going to put x is greater than 5 or x is less than -5. Notice I took exactly what it said and then I changed the sign and I changed the way that the inequality was going. Right? If you're not sure whether to put the word and or, when you graph it, you'll be able to figure that out. So I'm going to go ahead and graph, let's put -5 and 5 on my number line. I'll put 0 in the middle. Okay, x is greater than 5 is an open circle pointing to the right, and x is less than -5 is an open circle pointing to the left. So notice it's a disconnected graph, so I would for sure know that this is an or problem if I wasn't sure in the first place. And then we're done with that problem. All right, let's try another one. Let's say the absolute value of x is less than 1.5, and at this point in time, it would probably be a good idea to pause this and just try it on your own and see how you do. All right, so it's less than, so I'm going to have x is less than 1.5, and then x is greater than -1.5, and again, if we're not sure whether to put and or, just wait a minute till after you graph it. So I'm going to put -1.5 on my number line and 1.5. I'll put 0 in the middle. X is less than 1.5 would be an open circle pointing to the left. Greater than -1.5 would be an open circle pointing to the right. So notice we get a connected graph. So this is definitely an and problem. And if we wanted to rewrite that, we could rewrite it so that it looks like this. All right, let's try one where we have some numbers in there. Okay, this one is going to work the same way. It's going to be very similar to how we did when we solved equations. So I'm going to have x plus 2 is greater than 4. My other inequality is going to be x plus 2 is less than -4. Okay, so solving this first equation, or inequality, we'll subtract 2 from both sides. I'll get x is greater than 2. And then when I solve this one, I'll subtract 2 from both sides, and I'll get x is less than -6. So let's put -6 on the number line and 2. We'll put 0 in the middle. Okay, x is greater than 2 is an open circle pointing to the right. Less than -6 is an open circle pointing to the left, and it's a disconnected graph, so I know I'm going to put the word or in the middle, and that would be my answer. All right, let's try one that's a little bit more complicated. Let's put a 5 in here. Right, this one, again, we're going to solve it very similarly to how we did the other problems. I need to get rid of that 4 first, so I'll add 4. So I've got 2x minus 3 is less than or equal to 9. Now that I have the absolute value isolated, this is when I'm going to go write my two inequalities. So I'm going to have 2x minus 3 is less than or equal to 9. My other one will be 2x minus 3 is greater than or equal to -9. Do not write the two equations until the absolute value is all by itself on one side of the equation. All right, so now I'm going to add 3. I'll get 2x is less than or equal to 12, and then I'll divide by 2. So I'll get x is less than or equal to 6. So that's one answer. And then I'll add 3 over here. I'll get 2x is greater than or equal to -6, and then I'll divide both sides by 2. So I'll get x is greater than or equal to -3. So now let's go ahead and graph it. -3 needs to go on the left side, and 6 needs to go on the right side. So less than or equal to 6, there'll be a closed circle heading to the left, and greater than or equal to -3 will be a closed circle heading to the right. So notice it's a connected graph. So we can put the words and in there. And if you would like to rewrite your equation, it would be -3 is less than or equal to x, which is less than or equal to 6. Either one of these is 100% acceptable. All right, our last one, you might want to, again, pause this and try it on your own and then come back and see how you do. The first thing that I'm going to do is add 2 to both sides. So now I'll have x plus 4 is greater than 8. Now is when I get to write my two equations. I can't do that before the absolute value is by itself. So now I'm going to have x plus 4 is greater than 8. My second inequality will be x plus 4 is less than -8. So now we're going to subtract 4. I'll get x is greater than 4. Here I'm going to subtract 4, and I'll get x is less than -12. All right, so now I know that -12 needs to go on the left, and 4 will go on the right. And let's see, x is greater than 4 is going to be an open circle pointing to the right. Less than -12 will be an open circle pointing to the left. So since it's a disconnected graph, we'll put the word or, and my inequality is done. So hopefully now you can solve an absolute value inequality.